Alright, so we're going to be taking a polynomial that is in standard form, and we are going to find the real zeros. There's a little bit of a process involved with this, so we're going to go through and show you a few little tricks along the way. The first thing we want to do is get our list of P's and Q's. This one is pretty basic and straightforward because the factors of P are going to be listed over the factors of Q. And Q happens to be 1, so that makes this particular part pretty straightforward. Notice that it's plus or minus 1 all the way through the list of factors to plus or minus 20. We have to account for all possible zeros there in this list. So we're going to cheat just a little bit, so to speak. We graph the function and we notice that there are actually 3 real zeros. But what we're really going to do is we're going to pick a 0 from this graph and we're going to use it with synthetic division. Okay, so I decided to choose x equals -4. It doesn't matter. Any of those 3 zeros that you identify would work for this. I just chose -4 to be a little different, I suppose. Next, we're going to use this information, our given polynomial and the 0 that we just chose from our graph, x equals -4, and we are going to set up our synthetic division. If you recall, we're going to pull our information for the synthetic division from the coefficients and the constants, or the constant from the polynomial. And that's where these values, along with their sign, come from. So as we go through and we do synthetic division, we have to bring down that 1 and then we multiply that 1 that we brought down by -4. That product is going to go into the next column underneath 8, and then we're going to sum each column after we do the multiplication. As you see there, 8 minus 4 gives us a 4, so we begin to multiply. -4 times that 4 gives us -16, which the sum of that column is -5, and so forth. Ultimately, at the end, we want a 0 in that far right column. This is our quotient. One of the things that we got to focus on here is when we are doing synthetic division, each quote round that we do of synthetic division, we are reducing the degree of the polynomial by 1 each time. So that's a little thing to keep in mind here, because we start with a degree 3 polynomial, and when I go through and I do synthetic division once, that tells me that my first value of that quotient is going to be whatever the coefficient is, x squared. So that will allow me to write out the quadratic factor there. And that's important because we want to get the quotient to a quadratic factor. That opens the door for everything. We can then either factor if it's possible. If it is prime, then we would go ahead and use the quadratic formula. And remember, the quadratic formula always works. And then if it's a simple enough quadratic in there, we can solve by square roots. Here we have x squared plus 4x minus 5. And that's a pretty straightforward factoring situation. The factors of -5 that sum to a +4 are 5 and -1. So we go through and we confirm mathematically what we saw on our graph. Okay? And in all honesty, it's really the other way around. We're using the graph to verify what we are going to do and find algebraically, because this is going to be the same process that we use when we get into determining what our complex roots are given a polynomial, and just graphing alone will not work. We will have to go through and use synthetic division nearly at every stop. So I hope this helps you out with some of the more recent stuff that we've done, and thanks for watching.